Students, this is question number 11. We have been given the matrix T is equal to C0, 0D, which maps the point P of 2, 3 onto the point Q of 2, minus 3. Now we are asked to determine C and D. Okay, so let's do this. So this is a solution. So this is the transformation matrix, which is given as C0, 0D. It operates on 2, 3 and it produces 2, -3. So we have to get the value of C and D. So what do? You take the row, multiply with the column. So 2 times C positive 0 times 3 is equal to 2, row with the column. So 0 times 2 positive 3 times D is equal to -3. So you get first equation, second equation. Now this can be further simplified as 2 times C is equal to 2, which means C is equal to 2 divided by 2, which will give us a value of 1. So C is equal to 1. And from here you get 3D is equal to -3 and D is equal to -3 over 3, which means D is equal to -1. So therefore these are the values of C and D, and the matrix is 1, 0, 0, -1. Okay, that's the first question. Now they are asking us the second question. Determine the image of -5, 4 under the transformation T. Okay, so this is the transformation 1, 0, 0, -1. This is the point -5 and 4. We are asked to get the image. So row multiplied with a column. This will give you -5 into 1, positive 0, and that's followed by row into column 0, positive 4 times -1. That's going to be -4. So this is going to give you -5 and -4. So this is the image of -5 and 4. Okay, so let's move on. Now this is the next question. Describe fully the transformation. Okay, so what is the transformation? This is the transformation that we have, right? 1, 0, 0, 1. Now let me take a point. Let us take a point of say x, y in the plane. Right? The plane, the field can be r squared. Right? But anyway, these things are not required. We need to just focus on this point x and y. So what am I doing? I am operating the matrix onto the point. So 1, 0, 0, -1. I'm operating on the point xy. So what do we get? We get x times 1 is x plus 0, and then the second row with the column 0, -y, and what do we get here? We get x and -y. So what happens here is that every point in the plane is mapped by the transformation to its reflection across the x-axis. So So why do I state it like this? This is the definition you should provide for this question. Okay, so what is the meaning is, see, there is no change in the x-axis, but y-axis changes because we started off with xy, but we are ending with x and negative y. So y is exactly, or the image which we are getting is the reflection. The positive gets changed to negative. So that is the understanding that we have in this transformation. So that completes that question. We move on to the next one. Now for this question they are asking us to find the matrix that maps the point Q back onto the point P. So what they are asking us, they are asking us to find T inverse. This is required. Okay, so we know that. What do you know? We know that T is given as 1 0 0 negative 1. Now to find the T inverse, we will have to get the adjoint of T and divide it by the determinant of T. So foremost let me find the determinant of T, which means we multiply negative 1 with 1. 0 times 0 is going to give us 0. So this is going to be negative 1. So this is actually the determinant of the matrix T. Now to get the adjoint of T, we interchange the position of elements negative 1 and 1. But along the side there won't be any impact because the elements are 0 0. So therefore T inverse is going to be the adjoint, which is negative 1 0 0 1, and divided by the determinant, which is going to be 1 over negative 1. So if I operate with 1 over negative 1 all through, I would get 1 0 0 negative 1. So this is going to be my T inverse. Now in this question we are asked to represent the vectors in the form of xy. Now OP vector, clearly from the figure we can see the value of OP vector, which is going to be 4 negative 1. Okay, now next is we will have to get a QR vector. So you might be wondering, how are we getting this? Now this is actually nothing but we subtract the point O, which is 0 0, from P. So actually what is OP is nothing but from 4 we take away 0, from negative 1 we take away 0. So we get 4 and negative 1. So that is OP vector. So similarly QR vector, to get QR vector, what do? We subtract the point Q. So what is Q? Q is it is located on the y-axis, right? So it's 0 and 2. So we subtract 0 2 from R. R is R vector is represented as 3 and 7. So QR vector is going to be 3 minus 0, 7 minus 2, which is 3 and 5. Now for the next question they are asking us to find the magnitude of QR vector. In this case it's going to be 3 squared plus 5 squared, which is nothing but 9 positive 25, which will give us a value of root of 34 units. Okay, that's the solution for this question. Now the last problem, we are actually given the point S. It's actually OS. OS is given. So what we have to do is OS is given as 7 and 4. Okay. We will have to represent this on the diagram. So this is the original diagram. Let me show you the original diagram.